Hello everyone. A warm welcome to all of you for the learning series Programming in Python. This course will be helpful for beginners in Python as well as early stage developers from a certain point. In this course, I'll guide you through the fundamentals of Python programming language with examples and programming to solve simple problems to dealing with complex requirements. This series will also be very helpful to students of grade 11 and 12 learning computer science as a subject. Let's begin. We'll take a quick look at the list of topics that we would cover to begin with. Anyone looking to master Python should have a solid understanding of these fundamentals before going on to writing complex programs. Let's take a quick look at these topics. First one, getting started, which is more of an introduction to basic building blocks. Flow of control, which means how we control the program to take different directions and do certain activities. Functions, which are basically set of instructions that can be repeatedly called to execute the instructions. Strings are nothing but operations on text values. Lists, how we handle a set of numbers or strings or alphanumerics as a group. Tuples and dictionaries are different forms of lists. We'll come to that in a short while. Exception handling. When there are errors in the process, either expected or unexpected, how do we handle those errors and exceptions? File handling is nothing but how we deal with files in a whole or part of the files, how to read, write, transmit, and so on. Stack is another concept where we deal with set of instructions or set of data that can be handled in a group. Queues, how do we handle a bulk of information or instructions in a series. Sorting, we know sorting. Searching, how do we search for certain keywords or specific data. Let's proceed with the getting started section. As I mentioned earlier, getting started is more of an introduction to Python as a programming language and its basic building blocks. Before that, let's quickly touch upon what is Python. Python is a high-level computer programming language created by Guido van Rossum. The first version was released in the year 1991. It was more of a self-initiated programming language development rather than from an organization. He created it out of his own interest and went through so many changes over the past almost 3 decades or a little over 3 decades now. The latest version we have officially announced is version 3.11.4. These are some of the high level programming languages. Let me quickly touch upon what are high level programming languages and what is meant by low level programming languages. High level programming language is nothing but a programming interface that is an option to write human like or human language like instructions, which will be converted into machine understandable instructions through a compiler or an interpreter. Python is one of a high-level computer languages like C or Java or C++, and so on. The next point is Python is a general-purpose language, meaning it can be used to create a variety of programs. Python is not limited to a certain specific business function or any other specialty functionality. It can be used for any kind of programming, right from simple arithmetic operations to complex artificial intelligence programming. As I mentioned, it's not a specialized or problem specific programming language. It has less cluttered and simple syntax and grammar. What do we mean by this? If you're familiar with any other programming language like C or C++ or even Java, for simplest of operations, we need to write multiple lines of code. For example, an addition of two numbers, you have to declare a couple of variables, you have to write the operation and then see what is the output. You have to write instructions for each of these. In the case of Python, it's much simpler. All you have to do is number number one equal to number one plus number two. The declaration of all three variables with the data type and the operation is defined in one single statement. Python is free and is an open source language. There is no licensing, as well as users or the programmers have the ability to contribute to the development of the programming language. Python can be used to build websites and develop application software, automate tasks, and conduct data analysis. These are just a few examples. Python is case sensitive, so we have to be careful with the usage of keywords or identifiers. Even if the same word is used with different cases like upper or lower case, the meaning is different or the data it refers to will be different. So we have to be very careful over there. It's portable and platform independent. What do we mean by that? When we say portable, the programs created with Python can be moved on to other systems and any operating system like Windows or OA, Mac OS or Unix and so on. It has a lot of predefined functions that make development much easier for the programmers. Some of the advanced usages, automation. I mean, Python has been used for automation for a very long time now. And recently, in the past few years, Python has taken over the artificial intelligence world by storm and data analytics with many more. Now, let's look at the process to setting up the coding environment. I've just given a screenshot of the python.org website. Let's go through the instructions first. Go to python.org. Under Downloads tab, hover on Windows and click Python 3.1.11.4. That's the latest version. Go to your desktop or laptop's Downloads folder. You will see the listed executable. That's Python 3.1.1.4 AMD64.exe. Run the same and install with default options. Both Python 3.1 interpreter and IDL will be ready to use. You will be able to see that. We'll quickly look at how to do it. Go to the address bar and type python.org. Under the downloads, hover over Windows, downloads for Windows, Python 3.1.1.4. Click on this. See the download happening. Go to the downloads folder in your laptop or desktop and double click on the executable. I have already done it on my laptop. So just double click on it when the process starts. Allow the process to run on your laptop or desktop and go for a default installation. Once the installation is complete, you can check the install software, checking into your Windows startup. Here you have the IDLE and the documents. Coming back, a quick note. Python can be used on Unix and iOS also with respect to download and installation. Now that we have installed Python on our system and we have access to IDLE, IDLE stands for Integrated Development and Learning Environment. How do we use this platform or development environment for programming in Python? Let's take a look at the working modes. First is the interactive mode. In this mode, the user is given the facility to enter one instruction or statement at a time. It processes individual statements right away. And as I said, it's one instruction at a time or one statement at a time. And these instructions cannot be saved. Once entered and executed, I mean, the Python interpreter reads it, processes, and takes the action given in the instruction. But once completed, if you want to do the same process or statement or instruction again, you have to retype or copy and paste. There is no mechanism to save this instruction somewhere to re-execute automatically or on demand. The next mode is script mode. In this mode, set of instructions can be saved as a Python program. The extension is .py. It can be saved as a file and executed any number of time on demand. To run the program, type the file name with the path at the prompt or go into the IDLE and go for the run module option of the run menu. Let's look at some examples for the working modes and I'll show you on the Python development environment in these modes. First is interactive mode. Here you can see 1 plus 2 equal to 3, but I just type 1 plus 2 and the output is, when I press enter, it comes out with 3. But if you want to see the 3 or execute 1 plus 2, I have to type it again. Print hello there, happy learning Python. And once I print it, this is syntax. We'll go to them a little later. But if I want to execute it again, the 1 plus 2 or the print statement, I'll have to type them all over. In the script mode, however, I can type any number of instructions and save it as a Python program, .py program. In this example, I have given p1.py. I have two different instructions and the output, once I execute in the run option or run menu option, there is a run module option and the output comes like this. This is the ideally shell where I go into interactive mode. I say 1 plus to the same example I had given in the presentation. I get an answer 3. But if I want to do it again, I don't have a way to retrieve it from somewhere like any other your command prompt, go back and bring it to execute. But you have to type 1 plus 2 again to get the 3 or any other instruction that we can give. And again, print, for example, if I want to do the print again, it has to be written all over. This is an example for your interactive mode. For using the script mode, as I said, we can give instructions, collective set of instructions within a file and save it as a Python program to execute together, right? So I'm going to create a new file where I say print hello there. Okay. Just to remind, as I said earlier, Python is a case-sensitive language. So if I give print with uppercase P, it's going to throw an error. So we have to be careful over there. I'm saving this as a Python file. By default, it'll show the py extension. I'm saving it here. I go to the run menu option and run module. I get it on the ideally shell as an output. So this is how we use the script mode of execution of Python program. In the interpreter interactive mode, it's just one statement at a time. Here you can have multiple instructions run together after saving as a program. Now let's take a look at the keywords. Keywords are reserved by the Python programming language, meaning we cannot use them as a variable or function or any other identifier name in our programming. These are reserved by the system, and there are around 35, maybe more coming up. But these words cannot be assigned to a variable as a name or a function or any other identifier. There are 35 keywords as of today. Now, let's look at identifiers. What are identifiers? Identifiers are nothing but names given to program entities like variable, function, dictionary, and so on. This is to differentiate or giving a notation to any particular entity in a programming language. How do we differentiate between one data from another? So these identifiers have to adhere to certain rules, like any other programming language. Python also have certain rules. They should start with an alphabet or an underscore, followed by any alphanumeric combination. In other words, every identifier should start with an alphabet, a letter, English letter, or an underscore. There are certain cases we use underscore and it cannot start with a number. An identifier cannot start with a number. There's no restriction on the length of the identifier. It can be any length, but we have to keep it readable and manageable. We cannot give a 100-character identifier name and then finding it difficult to use it in our program. And keywords are not allowed. We saw earlier that there are 35 keywords in Python. None of the keywords can be used as an identifier. And special characters like your ampersand, your at symbol, hash symbol, dollar symbol, and so on cannot be used in an identifier. Let's look at some examples for identifiers. Total equal to number 1 plus number 2 plus number 3. All four are identifiers. Total will have or hold the sum of number 1, 2, and 3, but all four are identifiers and they will be having a data type of number. Final status equal to completed. So this is a string identifier which has a string value assigned to it. And this is some chunk. As I mentioned earlier, it should start with an alphabet and it can be of any length. So I wanted to give an example for that. So it can have any number of characters, but I just gave a value of chunk assigned to this particular identifier and so on. What are variables? Variable is an object in Python that is uniquely identified by a name. Earlier we saw identifiers, right? We have a total, final status, and the junk identifier. These are all variables assigned with a particular value. We are giving a name, a uniquely identifiable name to an entity that is called a variable. Variables are stored in memory, can store values of string, alphanumeric, or numeric, as we said earlier. And assignment statements are used to create variables and assign values to them. This is one of the differentiator, or we talked about less cluttered code or less cluttered statements and better grammar. So here is one example of it. In other high level programming languages, we have to declare a variable, assign a data type to it, and then make assignment statements to assign values. But in the case of Python, you don't have to declare a variable, it automatically recognizes based on the value. And all you have to do is create an assignment statement. For example, total equal to is the assignment qualifier. Total equal to number 1 plus number 2 plus number 3. The plus symbol is an operational symbol which denotes addition, but the addition of these three numbers, the value of addition of these three numbers are assigned to total. This assignment is able to create all four identifiers: total, num1, num2, num3. It's able to create all four identifiers and assign the values that we enter here. Here are some examples for variables. Create and assign. Stage equal to go plus ahead. It takes up string values. When we print the message as a variable, the message is a variable here. When we print it, we get go ahead. Average equal to 79.2. Here it's a number. We will look at the types of number variables or number type data. Here it's a float. It's called float, where we have a decimal. So print the average mark is average. We have an output of the text plus the variable average put in together. The next one is comments. What are comments? Why we use them? Comments are added to give a remark or notation about a line of code or a function or the program itself, what this program intend to do, or if you are going to explain what this small section of code do, or a function, or even a particular line, what this particular explanation or instruction mean. Used mainly to add some description about programmer parts of it. In Python, it starts with hash symbol. When it is different for different programming languages syntactically. For Python, it starts with a hash symbol. Anything that follows, any instruction or any text that follows the hash key will not be executed by the interpreter. It considers that part to be a comment. It's just a notation and not something that it has to interpret and take an action on. This is done to make sure the programmers understand what is being done, either a section of the program or the entire program itself. In a typical development environment, one person is not going to be the owner for a particular program, right? So when a particular individual develops a program and somebody else is going to maintain it or make changes, a description like this, a comment like this, will be very helpful to understand which part to analyze, which part to change, and who has done what date, and so on. So here are some examples. Hash. This program calculates the annual production of mobiles. This is just a comment. As it doesn't have anything to do with the execution itself, but it says what this program does. Similarly, this is the start of the function. It could be a set of instructions or even one statement called repeatedly over the program. So just a notation for a start of the function or a version number. a program can have multiple versions. It's a good practice to keep versioning the program as and when they go through changes. So giving a version number to the program itself, a comment can be helpful. And there are so many reasons. You can only imagine what can be, as long as there is a hash and whatever is written after that, the Python interpreter does not consider them to be part of the program itself. Next are objects. Python is an object-oriented programming language. This particular course, I'm not going to talk about object-oriented programming in detail, but Python is one of the object-oriented programming languages like C++ and Java. Objects are a representation of real-world entities. And any object, for example, take a car. Car as a whole, it's one unit, but it has many parts. Each part having a function of its own, an operation of its own. So you can consider a car as a real-world entity, which can be represented in terms of objects. Each object has an attribute and a method and is instantiated by a class or class hierarchy. What do you mean by attribute and method? It's basically a data and what is done with the data. That's the object definition. In Python, one or other of the object entities may not be present. If you take C++ or Java, whenever there is an object defined, both the function and data should be defined. In the case of Python, one of them need not be present. Either a function or the data need not be present. It can still be treated as an object. Every entity in Python is treated as an object. Python treats every value or data as an object on the basis that it can be assigned to a variable or passed to a function as an argument. That's what I mentioned a little earlier. Every entity in Python is treated as an object because the value can be assigned to a variable or passed to a function as an argument. Each object is assigned a unique ID that remains the same for the object's lifetime. When you say unique ID, is an identifier for the particular object for a value. I can use different names for the same value, but ID remains the same for that particular object. The value of the ID can be retrieved by ID of the variable or the object. For example, num equal to 20. Num is the variable or identifier here. The ID of num can be retrieved by ID of num. This will return an object ID. It's a numerical value which is unique for every object. Let's talk about data types. These are all the data types that are available in Python. First one is the numeric. Numeric has three different subsets: integer, float, and complex. Set, sequences. Sequences are of types string, list, and tuple. Boolean, and dictionary. Boolean can also be considered or is considered as a subset of the numeric data type. We will look at it at a later point. And in addition to the data types, Python data types are classified into two major varieties. One is mutable, the integer, float, complex, boolean, string, and tuple are mutable, and the other is immutable. There are sets, list, and dictionary. Mutable means the values assigned to these particular data types can be changed over the course of program, but immutable ones, the values cannot be changed during the course of the program. We will look at each data type a little bit in detail, going through each and every subset. First one is the numeric. Numeric data type stores numbers only, and it holds every variable or identifier stores just one value. If you want to look at a particular variables or identifiers data type, we can use the below piece of code. For example, here num1 is assigned of the value of number 10. Since there is no other depiction, either a decimal or quote to make it as a string, Python reads it as a number assigned to the variable num1. Remember, we saw that the assignment and creation of a variable and assignment of value happens in the same statement. This is a classic example of it. Num1 equal to 10. If you want to see the type of num1 after this assignment, give the command type of num1. It gives a class. This is the output of this particular entry. Class is int, meaning the data type of this particular variable is integer. And these are all the, I just gave one example, but these are the different types of numeric data. First one is integer, which can hold numbers, whole numbers, both negative, positive, and zero. Float is real or float numbers, both positive and negative, decimal numbers. And complex numbers are a number with plus or minus a j with a uh, associated number. So these are the three major types. As I mentioned earlier, Boolean is also a subset of numeric, which we'll look at later. Yeah, Boolean holds one of two inbuilt values, true or false. I remember Boolean, we would have seen one or zero, true or false, yes or no. All those things are Boolean. Any uh, entity that can hold one of two values can be considered Boolean. In this case, it's true or false. The class type or the type of this particular data type is depicted by bool, bool, bool. The most important aspect that we need to remember here is this true or false assignment should start with an uppercase trf. If it is true, start with uppercase true. If it is false, start with uppercase f, false. Python will throw an error if it is uh, not starting with the uppercase letter f. Example here, variable 1 var 1 equal to true. I've highlighted t just to reiterate. The type of var 1 will be printed as bool. Next data type is set. Set is an unordered collection of items of different data types. Remember, in the numeric, we had integer, float, and complex. But a set can hold a number, an alphanumeric string. Different data types can be part of a single unordered collection. Iterable in the sense you can loop through the set. Mutable, that means it can change data, but it cannot have duplicates. If there is a duplicate, it will be ignored in the process of printing or even iteration. Items are separated by commas and enclosed in curly bracket. Yep, just please remember this statement. Items are separated by commas and enclosed in curly brackets. The keyword is curly brackets here because there are two other data type entities that will be enclosed, one by open braces and open in parenthesis, the other one by square brackets. So please keep a note of it or remember this. Once created, elements of set cannot be changed. Duplicate items will be removed from output. As I mentioned earlier, this cannot have duplicates. So if there are duplicates, the output will have only one entity among the duplicates. Here are some examples. A comment, create a set set1 equal to, in curly brackets, a number, another number, both are integers, third number being float, and a text within quotes. When you print this set, when print the type of the set, you will have the type as set. And if you actually print the, or if you want the actual values in the set, just print of set and you get the actual values in the same format that is assigned with. Next, data type sequences. As we saw earlier in the table or chart, sequences have three different types. First one is string. String is a group of characters that can be alphabets, numbers, alphanumeric, or special characters, including spaces within single or double quotes. This is very important. It's basically anything within quotes. Whatever goes within the double quotes is considered a string and processed based on the instructions given. Numerical operations not possible on string type. If you have string as values, you cannot have numerical type operations like plus, minus, or add, subtract, and so on. Here you have a sample of string. String 1 equal to hello friend. String 2 equal to 452 within quotes. Again, here, though it's a number, it's treated as a string. List. List a sequence of items separated by commas and enclosed within square brackets. Remember, we saw a set earlier in curly brackets. Now we have square brackets. List equal to a number, integer number, float, a text, another text, and an integer, all in square brackets. If you print that, you get the value getting printed. Tuple is a sequence of items separated by commas and enclosed within parentheses. Tuple TP1 equal to numbers, text, within quotes, and another number. When you print it, you get as it is. Next data type is a dictionary. Dictionary is an unordered collection of data values used to store data like a map. This is the difference. In the other types, you have the data values directly going into a list in sequence, and that's it. You don't have a mapping process or one-to-one correspondence within the set or tuple or other data type. But in the case of dictionary, you have a key value pair or more than one key value pairs separated by commas. Dictionary items are enclosed in curly braces as a whole. I mean, you have a key value pair, a comma, another key value pair, comma, another key value pair, and so on. All of them enclosed within curly braces. If you want to access value in the dictionary or defined dictionary, you extract the value with the reference to the key. I mean, show me the value of this key, show me the value of the other key. You can extract the value of a particular key to print or process or assign to some other variable, and so on. Here is an example. It's a screenshot from the IDLE dictionary, make, model, and price. With a key value pair, key is make, model, price, and the values being BMW X7 and INR 10 million. When you print, you get the values as defined or as entered. When you print the price of dict1, when you say price, you have the third key as price. It has to match exactly. There's no there should not be any difference either in the text or case also. Remember, Python is case sensitive, so if you have a key defined in a particular nomenclature, it has to exactly match when you try to extract the value as well. So when you print the value of a particular key, you get the value in the output. Next, we'll see operators. Operators are used to perform operations on values and variables. These operations can be mathematical, logical, comparison, and so on. Here is a broader list of operators in Python. One is arithmetic operators, second is comparison and relational operators, third is logical operators, assignment operators, identity operators and membership operators, and bitwise operators. We'll look at one by one. Arithmetic operators. These are used for mathematical operations, basic addition, subtraction, and division, multiplication. This is the basic syntax. The basic syntax is X operator Y. X and Y are called operands on which the operation is being done. The mathematical operation is being done. In the case of division, we have three different operators. One is division, plain division, X by Y, which gives the quotient, the exact result. X slash slash Y, double slash Y, gives the quotient after removing decimals. It gives the whole number. And percentage gives the modulus, meaning the remainder. And the last one is X exponential Y. Next set of operators are relational operators or comparison operators. We know about these, we have been learning about this from junior classes. Greater than, less than, equal to. Equal to, we have to remember, a single equal to symbol is assignment. Variable equal to value, that's assignment. So to differentiate, there are double equal to symbols to say if a particular variable is equal to variable other than another variable. Not equal to, greater than or equal to, and less than or equal to. The next set of operators are logical operators, and, or, and not. X and Y, if true, the result is true. If x or y is true, either of them is true, the result is true, and not of x. The next set of operators are assignment operators. For example, equal to as an assignment operator assigns the value of the right side expression to the left operand. Here we have x equal to y plus z or z. So it operates, it completes the operation y plus z first and then assigns the results to x in the left operand. The next one is plus equal to. What it does is it's basically the equivalent of a plus b being done first. We have two variables being operated upon, and the result being assigned to one of the variables. So instead of writing a equal to a plus b, there is a simpler way to do it. Similarly, minus equal to is basically doing the operation of a equal to a minus b. Does a minus b first and then assigns the value to variable a. We have to remember that there are two variables a and b. There are operations or there are two different operators happening in one symbol, but one of the variables is changing the value. B stays as is, but a's value is changed with the value of the operated variables a and b, and so on. You have multiplication equal to, division equal to, slash slash equal to, and modulus equal to. Continuing with the assignment operators, we have exponent equal to a star b equal to a put to the power of b assigned to a back to a. And there are bitwise and or XR right shift and left shift operands. We have to explain what are bitwise operations and then come back to the operators. So we'll look at it a bit later. The next set of operators, identity operators and membership operators. Identity operators are used to find out if the value of a variable belongs to a particular type or not, and also to find out if two variables are referring to the same object or not, meaning same memory position or not. These are all the operators. Is it is true if the operands are identical. For example, a is assigned with the value 10, b is assigned to the value 20, c equal to a. If print a is c as the output will be true. Here it is checking if a is c, and we have assigned c to be a, meaning c is also having a value of a, and I'm printing a is c, so the output will be true. Is not is the opposite of it. So I have 10, a equal to 10, b equal to 20, and the same c equal to a. But if I print a is not b, what I'm checking is print a is not b, meaning if a is not b, give me the result. The output is also true here because a is 10 and b is 20. They're not same, so the output is true here. Then we have the membership operators, in and not in. In is used to find out, or in is in results in true if the particular value we are checking is part of a sequence or present in the sequence. X equal to 24, y equal to 20, and I have a list of 10, 20, 30, 40, and 50. If x not in list, print x is not present in the given list. I'm checking if x is not, else, meaning if x is present, then print x is present in the given list. Similarly, the same conditions if y is present and y is not present. In the case of in, when x is equal to 24 and list has 10, 20, 30, 40, 50, x is not present in the list. So wherever we are checking x is not in the list, it's going to return true. Similarly, not in. For example, x is equal to 24, which is not in the list. So whenever we are checking x not in the list, it's going to print x is not present in the given list. The next set of operators are bitwise operators for operations on binary numbers. We have to explain what they are. What are the operations before coming to the operators. So I'll have to explain how bitwise processing works. So we'll come to that later. I'll take it as a separate topic at a later point. Next, we'll see expressions. Expression is a combination of constant, variable, and operators, and they always evaluate to a value. Just a note, a standalone value is also considered as expression, but an operator is not. Here are some basic examples, simple examples. X equal to 5 multiplied by 6, When I print it, I get 30. And similarly, y equal to 4 multiplied by 6 minus 7, I get 17. A equal to 7. This is the third point we saw. A standalone value is also an expression. So here, A equal to 7 is an expression, but P equal to plus symbol is not an expression. That's the basic understanding. And the first line says it can be constant variables and so on. So instead of 5 multiplied by 6, I can have C equal to x into y into a. Now we look at the precedence of operators, meaning in a given set of operators, different operators in the single statement or instruction, what is executed first and what next. Remember, we know about the arithmetic operators, multiplication, division, addition, subtraction, executed in the particular order. We have similar order for expressions. We have different operators that we have seen. So which set of operators are executed first and what next? Here is the total list. We have parenthesis executed first. Python interpreter sees for parenthesis, and anything that is within the parenthesis is calculated or operated upon first, and then what's outside. The next one is exponents, meaning power, and then comes the unary operators, bitwise operators, which anyway we'll explain later. Multiplication, division, floor division, and modulus. The next being addition, subtraction, and skipping the bitwise, we come back to comparison operators and logical operators. The next topic is statements. Statements are units of code which Python interprets and executes. For example, x equal to 4, it's an assignment statement. I mean, it's also an expression, but for Python interpreter, this is a statement, it's a technical term statement that Python interprets, processes, and assigns the integer value of 4 to x. Cube equal to x to the cube of 3, x to the exponent of 3. That's an assignment statement again. Print x comma cube, print both, which is a print statement. So statement is a technical term available in any programming language. What is a statement? It's basically an instruction. And we'll come to the input and output. Input and output are basically how we give information to the system or Python programming language, and after processing, how Python sends out and where it sends out is the output system. Input of prompt enables user to interact with the system when required. When we use this, the Python program waits for the user to enter some information it expects. It will stop until user gives an input. So even if a basic or simple enter will be considered as a response from the user, and then it goes on to process what is being entered by the user. And user entry is converted into a string data type. No matter what the user enters, it could be number, it could be alphanumeric, it could be float, integer, whatever may be the case. For example, please enter your name, I enter my name. Please enter your age, I enter number. Both these entries are converted into string value to be processed within the program. And if you want to change that data type into the expected one, we have to go and code within our program. By default, the Python interpreter considers or converts any entry from user into a string data type value. For example, num equal to input of enter number. So the Python throws the statement enter number and waits for the user. So until the user presses enter, it doesn't do anything, just waits. Output, we have print statement, prints the message to the screen or any other standard output device. So we can redirect the print to a different output device that can be defined in the code, and appropriate connections and ports, we can do the print into any standard device. The syntax of print is print of the value, or you can have separator. End will be slash n. Separator you can define as anything you want within quotes. There are some examples. The next one is type conversion. Type conversion is nothing but converting one data type into another data type as we need in the processing. There are two types. One is explicit conversion. This is done by the programmer or the developer and forced in the program. It's also called typecasting. The next one is implicit conversion. This is done by the interpreter automatically based on information that we give, either in the assignment statement or in expression. The resultant is read by the Python interpreter, and then some decisions are taken by Python for data types specifically. Explicit conversion. What can be converted into what? Interfx converts the operand or the variable x type from anything to integer. It could be text, it could be alphanumeric, whatever. But resultant data type will be integer. Similarly, float will be the resultant will be float, and so on. So here are some examples. Next type is the implicit conversion. It's also known as coercion. As we saw, it's done by the Python interpreter itself and not forced by the programmer or the developer. Here is an example. Num1 is defined as 10, num2 is defined as 20. When I add sum1 equal to number 1 plus number 2 and I print, the output is 30.0, which is a float. So by default, it is taking the data type of the larger number. For me to print 20.0, it takes more space than printing number 10, right? So it automatically converts the type of data type of the someone to be float. So if you want to check that type, you can always print the type of someone and it shows float. So it's done with the Python interpreter. I did not code for a type for someone, right? So this is called implicit conversion by the Python interpreter. Debugging. Debugging is the process of identifying errors. You would have come across this term quite frequently. So it's a process of identifying errors. When we write a program and we run the program, we come across errors and we want to find out where the error started, what is causing the error as such. So this analysis is called debugging. Identified errors should be fixed. I mean, the idea of creating a program is to make it do something for us, make things easier for us. So if there are errors, it's not going to be very useful. So during the process of debugging, we identify the errors, and these errors need to be fixed. There are at a high level, there are a few error categories. Syntax errors are errors where the Python rules are not followed, meaning there is a way you have to write a Python code, and if that is not followed, it's going to throw up an error saying there's a syntax error. Remember, we saw an error as a syntax error during the assignment, or an operator being thrown as an error for not being an expression, right? The next one is logical error. This is where the interpreter accepts the syntax, meaning technically or from the Python's point of view, the lines or statements are correct, but the results are not as we expected. So this is basically from the programming part of it. How I wrote the program, what I intend to do, I did not really bring out onto the code. So these are called logical errors. And runtime errors are abnormal termination due to some issue with the system itself. Say it's not able to access a particular memory, or divide by zero error during the process. Those things are called runtime errors. So let's take a quick recap, and you can post the queries for me to respond to you guys. Let's read through one by one. Thanks again. Please post the queries, and I'll upload the next topics in further videos. Thank you.